Okay, Assalamualaikum. My name is Muhammad FESEM Ismail, and today I would like to present about my final year project, which entitled is the effect of chromium, titanium, and zinc doping in nickel-rich cathode material on the structural and morphological studies. So, what is the NCM811 problem? There is no doubt that the NCM cathode material have high capacity and can be implemented towards achieving the success to be used as a source of energy in the future, but the main factor that was very worrying that is the K-ion mixing that happened in this NCM cathode material. Based on the factor that was having by this NCM811 cathode material, I had done several synthesis of pristine NCM811 dope and co-dope and used the SRD instrument in order to satisfy the all of the synthesis process can reduce the K-ion mixing problem. So in the analysis of SRD measurement, I have done several observations on the phase and structural of all the samples that have been synthesized during the lab session. So number one is the observation on the phase of the sample. According to the SRD results of pristine NCM811 dope and co-dope shown in the next figure, it was revealed that all the synthesis samples were pure and single phase, which is isostructural to Li and IO2 that can be assigned to the alpha and NFeO2 structure crystallizing with the R3M space group, which is the similar structure in ICDD database pattern of 01077226. However, it was found that all the sample except 1% chromium dope NCM811, the 104 peak are much higher than 003 peak, indicating a higher K-ion mixing in the crystal structure. Interestingly, it is different situation for 1% chromium dope NCM811, where the 104 peak are lower than 003, which indicating the K-ion mixing present in the crystal structure is lower as compared to pristine sample A. Number 2, the structure of sample. Next, the structure were carried out by calculating the reference intensity ratio RIR between 003 and 104 peak. Is the method that was used to evaluate the presence of K-ion mixing, and by having the RIR value higher than 1.2, it is reported that the crystal structure will have low K-ion mixing, which give a good K-ion ordering, which later yield a good electrochemical properties. Based on my findings, the RRI value for all samples except 1% chromium dope NCM811 are lower than 1.2, which indicates higher K-ion mixing present in the crystal structure, implying a poor stability. The RIR value for 1% chromium dope NCM811 is 1.22, which are higher than 1.2, implying this material has lower K-ion mixing and has the potential to show a good electrochemical behavior. Next is the field Emission Scanning Electron Microscopy FESEM. To further studies, only pristine and 1% chromium dope NCM811 sample are subject to morphological studies via FESEM, due to the positive result that the 1% chromium dope shown in NCM811. This also due to reduce the time taken for me in using this FESEM instrument. So I only take 1% chromium dope as this element only this element show the positive results. So this the FESEM image were taken at magnification of 5,000 times and 10,000 times for both samples, and the results are shown in the next figure. It can be seen that both samples have a very crystalline structure and similar type of morphology, which is regular shape, and nothing much change can be seen after chromium dope in NCM811. Next is the Energy-dispersive X-ray spectroscopy (EDS). Next, the Energy-dispersive X-ray spectroscopy (EDS) had been used on both samples, which is NCM811 and 1% chromium dope, to determine the elemental composition of the material. For the pristine NCM811 A, the results show that the manganese content is lower than theoretical calculate, which is supposedly 10%, whereas cobalt and nickel content are higher than the expected, which is supposedly 10% and 80% from total atomic percent respectively. According to EDS results shown for 1% chromium dope NCM811, it seems that the value obtained experimentally for chromium content is well agreed from theoretical calculated stoichiometry. The similar situation as pristine sample is happened for manganese content in the dope sample, where its value is lower than expected. From my point of view, the index of element distribution was not very much homogeneous, as there were some elements that are higher than the expected atomic concentration and some elements that are lower than the expected atomic concentration. Next is the mapping analysis. Lastly, the mapping analysis were done for both samples to see the elemental distribution throughout the sample, and the spectra are shown in the next figure. From the mapping analysis, it can be concluded that the elements are well distributed. Lastly, the conclusion and the recommendation. It was revealed that all the synthesized samples were pure and single phase, which is isostructure to LiNO2 that can be assigned to the alpha and A FeO2 structure crystallizing with the R3M space group, which is the similar structure in ICDD database pattern. Next, the RIR result shows that all of the sample does not fulfill the requirement, which all of the sample RIR value are below than 1.2, except for the chromium dope, which the RIR value is 1.22. Thus, the synthesis condition is recommended to be optimized further for all the dope and co-dope NCM811 material. As for the recommendation, I suggest further battery testing, as it will help to measure the electrochemical performance of synthesis material. I also would like to suggest to imply various amounts of dopant, whether by increasing or decreasing the dopant amount to observe direction and outcome towards the material after undergoing modification. Lastly, it was recommended that the surrounding of the environment should be in the correct condition, which can enhance the positive results obtained at the end of the experiment. So that's all for me. Thank you, and I hope you can enjoy my video.